All right. Day 4. Last day. Solving quadratic equations and inequalities. You know what's coming, so let's just kind of get right into the word problems. Before we start, let's make sure we have out our notes. Let's make sure we have our graphing calculator. Let's turn that graphing calculator on. Let's hit our y equals screen and clear anything out that is in there, making sure none of our plots are highlighted. And let's also make sure that we're looking at a standard window, so let's hit zoom 6. Okay, once you do that, let's hit clear and let's get started. Okay, we're going to be looking at projectiles. Objects that are thrown, like a baseball, a basketball, a football, like a pencil, or like the colored pencils that I might toss at you from time to time. So think those are all projectiles. Key formula that you're going to need to remember about projectiles is obviously that one right there. H equals negative 16t squared plus vt plus k. K, you know from chemistry, is your constant. In math, it's still your constant, but in this case, when we talk about projectile motion, it's going to be our starting height. Okay, so K is always going to be your starting height. Obviously, then V is going to be your velocity, T is going to be time, obviously H is going to represent the height. Okay, so let's kind of take a look at some problems. Take a second, read this to yourselves. All right, so because we're throwing it from ground level, think about how we represent ground level as a number with an initial velocity of 55 feet per second. The advice that I'll give you is always write the equation first, then get into answering the questions for A and B. So I'm going to write the equation first, kind of at the top. I'll show it to you the first time, negative 16t squared plus, obviously the velocity is 55. Ground level, we obviously represent by the number 0. Okay, so then for letter A, does the ball reach a height of 52 feet? So think H is 52. So what I'm going to do is plug in 52 for H, and now I'm going to see if it reaches a height of 52 feet. This is where your graphing calculator is going to come into play. What I want you to do is to hit y equals. Once you hit y equals, I want you to type negative 16. We don't have t's, so let's just use x squared plus 55x. I want you to type that into y1. Scroll down, and I want you to hit 52 in for y2, and I want you to hit graph. If you're looking at a standard window, what you should notice is that you don't see the entire parabola. What you're going to need to do, and what we're going to need to do the rest of this chapter, it's going to be important that you know how to manipulate your windows, meaning change your screen to the point where you can see that entire parabola. So if I look at my graphing calculator, I see that I can't see the top of my parabola, so I obviously need to change my window so I can see the top of that parabola. So what I want you to do, I want you to change your window to this. I changed my X, so if you hit window, it says X min. Notice I want to change my X min to -1. My X max, I want to change to +6. X scale, leave it the same. Y min, I want to change that. Well, obviously it's -10, so I'm going to leave it. But my Y max, we talked about we want to get our graphing calculator more upwards, so that would mean I have to change my Y max. The advice that I will give you, think about this number right here. I know that 52, if it's y equals 52, that's going to be a horizontal line at 52. That's how I knew that my y max had to be bigger than 52. So what I did is I just decided to change it to 60. So that's some advice that I can give you so far. So once I change my y max to 60, I want you to hit graph one more time. And voila, there is your picture. You should see there is the baseball, the parabola. You throw it, it reaches a maximum height, it comes back down to the ground. Obviously, that 52 is that line above there. The advice, again, I'd probably draw a picture of what that looks like on your calculator. So there is my ball. I decided to do it in red. There is the 52 feet. So now I know when I go back and I look at my notes when I'm studying, it says, does the ball reach a height of 52 feet? Well, look, the height of 52 feet, so obviously, no, it does not reach that. Okay, so take a look, letter B. How many seconds after the ball is propelled is it 42 feet above the ground? Okay, so now, same deal. Instead of 52, I'm going to plug 42 in there. Okay, so I'm going to go back into y equals. For y2, I'm going to make it 42 instead of 52. I'm going to hit graph one more time. There's the ball. There is now 42 feet. Oh, so I see that it actually hits it in two spots. Once on the way up and once on the way down. So there are the two spots that the ball is 42 feet above the ground. How do I find those two spots? Think about what we did on our graphing calculator. How do I find those two spots? Well, you should be saying to yourself, I know what I have to do is find the intersection of those two at those 2 points right there. So hopefully you remember how to find the intersection. I will do the first one with you, the one on the left. So if you forget, hit second and the trace button. That gets you to that calculate screen. Number 5 is the intersection. Is that the first curve? Well, at the top it says y1, so I'm going to hit enter. Is the 42, is that your second curve? I'm going to hit enter. Be careful. The one that you want to find, when it says to guess, you're going to have to get closer to the one that you want to find and hit enter one more time. You should have on your screen 1.1450, etc., etc., etc. If I round that off to 2 decimal places, it looks like that's my answer. So you try, find that second one, make sure you get 2.29 seconds. Pause your video, make sure you get that before you keep going. Okay, example 6, hopefully you read that and were able to generate that equation there. So I have that. What I'm going to do, I'm going to put that in my graphing calculator because I think it's important. Let's make sure that we see that parabola. So let's clear everything out of our y equals. Let's type that. And my suggestion, always start with zoom 6. Always start with a standard window. Okay, so obviously we're going to need to manipulate our window because it looks like all I see is a vertical line on my screen. That can't be right. I know it's got to be a parabola that opens down. So, again, some advice that I can give you. Take a look at this number right here. I know that number is my y-intercept, the point where it crosses the y-axis. So I know my y-max needs to be much bigger than 240. So what I did was to use a window that was a little bit different than that. I think I have the video, I think I have the window on here. We'll have to double check as we keep going. Letter A, take a look. How high is the rocket 3 seconds later? So I want you to think that is actually a time. 3 seconds later, so to figure out how high the rocket is, I can just do what I've done in the past. Plug in 3 wherever I see a T, do that in my calculator, solve it, and I get 576 feet. Letter B. So when was the height of the rocket greater than or equal to 496 feet? So now I have the negative 16t squared plus 160t plus 240. I have that in my y1. I'm going to obviously put 496 in for y2. And now I have to manipulate my window. If you take a look, let's hit window. What I did was negative 10. I did my x max as 25. My y min negative 10. My y max 650. If I hit graph, now I see that entire parabola. I see where it goes up. I see where it comes back down and hits the ground. I will ask you on a quiz, on a test, to identify what window you used to see your parabola. So this is going to be something that we're absolutely going to have to practice. So hopefully you're understanding where we're going from here, and we'll kind of practice that some more in class when we get there. All right, so I have my window. I have everything set. So if I think about what the picture looks like, there is my rocket. There is 496 feet. So when is it greater than or equal to 496 feet? Think, I want that area that I just shaded, that's where it's greater than or equal to 496 feet. So I think what I'm going to have to do is find those 2 points where it's equal to 496 feet. How do I find them? Think, find the intersection of those 2 points. I'm going to leave that for you. Try to find the intersection of those 2 points. When you found the intersection, the one on the left, you should have got x was 2. The one on the right, you should have got x was 8. So how long was it greater than or equal to 496 feet? Well, from 2 to 8 seconds, that's when it was greater than or equal to. So that means it was greater than or equal to for a total of 6 seconds. From 2 to 8 is 6 seconds. Last one, letter C. How many seconds until the rocket returns to the ground? So that's where it hits the ground. Think, that is the 0 of your function. Do you remember how to find the 0 on your graphing calculator? Hopefully, you remembered to find the 0 on your graphing calculator. You're going to go to second trace, which is your calculate screen. Number 2 is the 0. Make sure you're on the parabola. Left bound, obviously you're going to be somewhere to the left of your parabola. So if you look at my picture that I have, somewhere to the left would have to be somewhere over here. Right bound would have to be somewhere over here. So left bound, right bound, I don't need to guess, and hopefully you get 11.32 seconds. I'm anticipating lots of graphing calculator questions, so hopefully you got it. If you need to rewatch, great, do that, and we'll talk about it tomorrow.